In our question, a circular disk of radius a meter is charged uniformly with a charge density of sigma coulomb per meter square. Find the electric field intensity at a point h meter from the disk along its axis. So in this question, first we have to draw according to this question. You have to draw a circular disk. We have to find it's having radius a meter, and we have to find electric field intensity at this point P along its axis. This is point P. So at this point we have to find the electric field intensity, and this is at h meter from this circular disk. Now we can consider this circular disk in the question. The circular disk having the charge density sigma coulomb per meter square. So in that we have to first we can consider a small annular ring. It's having a radius of r meter and thickness is dr. This is r meter radius and its thickness is dr. This is r meter radius. Okay, so first of all we can find, due to this small annular ring having radius r and thickness dr, due to the small annular ring, what is the electric field density at this point P? Then we can integrate from this 0 to the whole radius a. Okay, so first we can find, due to the small annular ring, what is electric field intensity. Okay, so this disk is consisting of a number of annular ring like this having varying radius r. This disk is consist of number of annular rings like this. So here we considering a small ring having radius r. So when we consider this small ring, so electric field intensity has two components are there. One horizontal component. So due to this thickness at this, due to this radius of annular ring and due to this small thickness dr, and electric field intensity will be at this point will be in this direction. That is, horizontal component will be in this direction, and there should be a vertical component also that will be in this vertical axis. So similarly, if we consider the other point, other side, so the electric field intensity will having the horizontal component will be in this direction, and its vertical component will be in this direction. Okay, so similarly if we consider the other point along this disk, due to this other point the electric field intensity having two components, that is, one will be along this horizontal axis and one will be along the vertical axis. And similarly if we consider the opposite point also, the horizontal component will be along this direction and vertical component will be along this direction. So if we consider the all this circular radius, whole this radius, the horizontal component of the electric field intensity will cancel. So this component is, horizontal component will be in this direction. In this at this point the horizontal component will be in this direction, just opposite direction. So the horizontal component of this direction, this intensity and this intensity cancel. So the remaining is only the vertical component of the all the electric field all electric field intensities. So we consider the small annular ring having radius. Only the vertical component of the electric intensity will remaining existing. So the vertical component of the electric field intensity, vertical component of electric field intensity, that is we can represent it as dE cos theta. So vertical component of the electric field intensity at point P will be dE cos theta. Okay, so this is due to this small ring having radius r and its thickness is dr. Now we already in the question it is given as the charge density sigma coulomb per meter square. So we already studied what is surface charge density sigma. Sigma is surface charge density. Sigma will be equal to charge per area, that is Q by delta Q by delta S. So if you want to find the total charge Q, we can find as sigma into ds or delta S. Total charge along this whole circular disc Q will be equal to sigma into delta S or ds. Delta S and ds നമുക്ക് represent ചെയ്യാം. So here this total charge is sigma into ds, and here what is ds? If we consider the small ring, ds is 2 pi into radius r into this thickness dr. So if we consider the whole ring, the total distance ds is the circular ring, the distance the thickness is dr, means radius is r. So ds will be equal to 2 pi r into dr. This 2 pi r is perimeter, that into thickness is dr. So that is ds. Okay, so if we consider the total charge, Q will be equal to sigma into this ds is 2 pi r dr. Okay, now if we consider the equation of electric field intensity due to this small ring, what is electric field intensity at this point P? So we can take that is dE. dE will be equal to what is Q by 4 pi epsilon 0 r square. We know the equation of intensity is Q by 4 pi epsilon 0 into r square. So if we here we can consider the distance from this point P that we can turn to this radius circular ring, that is this distance is r, and this angle we can take it as theta. This distance is only r is from this point to this small ring r. Now if we consider we have to find this point to this whole circular disc. So this angle is, we can take it as alpha. Okay, so we are considering this distance is from this point to this small ring, that is radius r. So if we, in this equation we have to find the electric field intensity dE due to this small ring. So electric field intensity at this point P due to this small ring. So here the distance is r. Okay, so the total charge due to this small ring, the total charge is Q by 4 pi epsilon 0 r square. Then what is the equation of Q? Q we got as sigma into ds divided by 4 pi epsilon 0 r square. Now this is only the dE, but we already found out only the vertical component is existing. Electric field inde vertical component മാത്രമേ ഉള്ളൂ, horizontal components എല്ലാം cancel ആയി പോകും. So we have only the vertical component of the electric field intensity, that is dE cos theta. So we can write the vertical component of dE. Vertical component of dE that is dy. dy will be equals sigma ds by 4 pi epsilon 0 r square cos theta. Okay, so vertical component is d cos theta. So d is sigma ds by 4 pi epsilon 0 r square into cos theta. So that is dy. Now what we have to find? What we have to find is the electric field intensity at this point to the whole circle or whole circular ring. So it's having a radius from 0 to a. So we have to find total field at P. Total field at P, that is equal to, so in order to find the total field, what you have to do? Integrate dy. That is from r equal to 0 to a. The whole circular disc in the radius load we integrate from 0 to center to the radius of the circular ring is a. So in terms of theta, if you consider in terms of theta at r equal to 0, what about this angle theta? Theta is also 0. Then at r is equal to a, what about this angle theta? This r equal to a means the total radius is a, means the angle theta is varying from alpha. Theta is alpha because this point to this whole circular disc, this angle is alpha. To this vertical axis from this distance, the angle is alpha. So radius r is changing to a means theta is also equal to alpha. So here also we can substitute. If we are varying the r equal to 0 to a, we can consider the integration is varying from theta equal to 0 to alpha. Theta equal to alpha. Okay. Now again from this right angle triangle, if we consider this right angle triangle, if we consider this right angle triangle, this triangle, this is same as this radius r and this distance is capital R and this is h. Now if we consider the sin theta, what is sin theta? Sin theta will be equal to, opposite side is r and the hypotenuse is capital R. So sin theta will be equal to small r divided by capital R, or we can write it as r is equal to capital R sin theta. Now similarly, what is tan theta? Tan theta will be equal to that is opposite side by adjacent side, that is small r divided by h. So we can write it as again small r will be equal to h tan theta. So we can write it as this radius r will be equal to r sin theta, which is also equal to h tan theta. Okay, from this again we can write it as what is dr. dr will be equal to h into h tan theta differential edukka, that is h into tan theta differential is c square theta d theta. Okay, now we can substitute all these values to this equation dy. We can write it as dy becomes sigma by 4 pi epsilon 0. Instead of this capital R, we can substitute r by sin theta the whole square. Then sigma into ds ആയിരുന്നു, so ds is 2 pi r dr, then that into cos theta. Okay, now again we can rearrange this equation. Again we can write sigma by 4 pi epsilon 0 r square. Then the sin square theta comes to the numerator into 2 pi r. Then substitute the value for dr that is h into c square theta d theta into cos theta. So again we can write as when we rearranging the whole. So we can this r and this r square, this square will cancel, this pi and this pi cancel, 2 and this 2 will be cancelled. So again the c square theta we can written as 1 by cos square theta. So h also we can substitute the value for h also. So again we can similarly we can again write sigma by 2 epsilon 0 into here it is sin square theta, then divided by here there is r, then into c square theta is 1 by cos square theta. So here it is 1 by cos square theta comes, then here it is cos theta is there into d theta. So again we can write sigma by 2 epsilon 0 sin square theta divided by r we can substitute as r is equal to h tan theta. Then here we have again h divided by cos theta there, then into d theta. So this h and h cancels. So here is 1 sin theta into sin theta, that is sin theta by cos theta, again this is tan theta. So this again sigma by 2 epsilon 0 into sin theta. Here that is again sin theta by cos theta comes here, sin theta into sin theta sin square theta. Here we have this tan theta again is there, tan theta, here cos theta is there into d theta. This sin theta by cos theta again tan theta comes. So sigma by 2 epsilon 0 sin theta is there, this is tan theta and this is tan theta, so this both are cancels. So sin theta d theta. So this is only dy. What we have to find is e. So for finding e is equal to closed integral theta is varying from 0 to alpha dey. Substitute the value of dey. So here this dey, the direction is this normal direction, that is normal direction of this intensity. So we can show the direction as normal component. Then this again the direction is normal component, and this substitute the value for this dey, that is sigma by 2 epsilon 0 sin theta d theta, and the angle is varying from 0 to alpha. Now again sigma by 2 epsilon 0 comes outside, then integral sin theta d theta, angle is 0 to alpha. So what do you get? Sigma by 2 epsilon 0 integral of sin theta is cos theta. So cos theta, apply the limit from 0 to alpha. So finally we will get the equation of sigma by 2 epsilon 0 into, when we apply the limit, that is cos of alpha minus cos of theta is cos of 0. So what do you get? This is integral of sin theta, that is minus cos theta is there. So we will get this is minus of taking outside, this is minus cos alpha, and this is plus 1. So the remaining is e will be equal to sigma by 2 epsilon 0. This is 1, cos 0 is 1 minus cos alpha. This is direction is normal. So this is the intensity E due to this circular disc. E is equal to sigma by 2 epsilon 0 1 minus cos alpha.